Right, so today we're going to be talking about 10.3 experimental versus theoretical probability notes. So experimental is if you actually do the experiment, so like rolling a die 6 times. Experimentally, maybe you got three of those 6 times. But theoretically, so if you didn't really roll those 6 dices, theoretically you should get 1 out of every 6 rolls. Okay, so experimental, you actually do the experiment, while theoretical, it's a theory. It's what should happen in a perfect world, but it does not always happen in the real world. Alright, so let's go ahead and apply this. So use the bar graph to find the experimental probability of the event. So experimentally, someone already did all of this. So they drew blue 4 times. They drew red 6 times. They drew green 4 times. They drew yellow 2 times. Orange 3 and purple 1. So altogether they did 10, 14, 15, 16, they did 20. So they drew 20 times, okay? So the probability of this experiment that actually happened was drawing red. So they drew 6 reds out of 20 draws. And then we reduce it, so we divide by 2, which becomes 3 over 10. So my probability of drawing a red was 3/10 experimentally. Now drawing an orange, we have 3 oranges, so 3 out of 20, because we drew it 20 times. Okay, so on experimental, you put it over how many times you did the actual experiment. You did what, and then that how many times you got that outcome. Drawing not yellow, so everything but yellow. So yellow is 2 times out of 20, so not yellow would be 18 out of 20, and then we have to reduce it, so I'm going to divide by 2, and you should get 9 out of 10. So my probability of drawing not a yellow in this experiment was 9 out of 10. Drawing a color with more than 4 letters in its name. So blue, nope, blue has 4, more than 4. So red, no, we wouldn't talk about. Green, we'd talk about. Yellow, orange, and purple. We talk about all those because they have more than 4 letters in their name. So 4, 5, 6, 7, 8, 9, 10. So I get 10 out of 20, which then reduces to 1/2. So the probability of drawing a color with more than 4 letters in its name is 1/2. Alright, now, there are 25 students' names in a hat. You choose 5 names. 3 are boys and 2 are girl names. How many of the 25 names would you expect to be boy names? So, 25 students in total. So, when I think about this, 25 students in total, and then you chose 5 names. Out of those 5 names, 3 are boys, 2 are girls. How many of the 25s would you expect to be boy names? So 3 were boys out of 5. So I'm going to do 3 out of 5 would be the probability of getting a boy's name. And I'm going to go ahead and multiply that by that 25 to see how many should be boys. So if I take 25 times 3/5, I should get 15. So technically what I would think, probability-wise, I think that 15 should be boys out of the 25. Theoretically, we don't know exactly how many, but we think that's how many from what our experiment shows. Okay? Alright. Using a number cube to determine the theoretical. So theoretical, we aren't actually rolling it, we're actually just thinking about what would happen. So theoretically, rolling a 2. How many ways can I get a 2 on a cube? 1, right? And there's 6 different options. So rolling a 2 on a cube would be 1/6. Theoretically, you should get that every 6 times you roll the cube. Rolling a 5, same thing. There's only 1 5 on a cube. There's 6 different things you can get, so 1/6 would be the probability. Rolling an even number, so 2, 4, 6 would all be my even numbers on a cube. So 3 out of 6, which would be the same thing as 1/2 of the time. Okay. And rolling a number greater than 1. So anything greater than 1, which would be 2, 3, 4, 5, 6. So theoretically, 5 out of 6 times you should get a number greater than 1. Alright, experimental, just think you actually do the experiment. Theoretically, you just theorize about what should happen. Alright, that is 10.3.